Hey there. In this video, I'm going to teach you how to implement for loops in YASM x86-64 assembly. Although if you're using a different type of machine or a different assembler, this video should still be useful to you because it's mostly about the concepts involved in implementing a for loop. Okay, so for starters here, what am I even talking about? What the heck are you even talking about, dude? Imagine in a higher level language, we have a for loop here. And so we have like for size type I equals 0, I is less than 99, I plus plus, right? Probably most programmers looking up assembly on the internet probably are interested in, or probably already know how to implement for loops in C++. So let's just pretend that you do. And so inside of your for loop, we'll do stuff. And what happens here is, well, this for loop is going to run 99 times. It's going to start at 0. And, so we have like an initialization part right here. Maybe I should copy paste this and kind of break down the parts. We have an init part here for the for loop. We'll say init part. And then here we have a check part. We'll continue to loop as long as this expression is true. You can make a big complicated expression if you want to, but we'll just keep it simple for this video. So I'll call this the check part. And then we have sort of an update or a maintenance part. So I'm going to call this the update part, where we increment our counter variable, move pointers, even call functions, do whatever it is you think you need to do to update the loop so that it runs it, so that the loops don't actually have to be integers. But in this case, I think it's easier to understand what the loop is doing if we just kind of break down these parts. Anyway, so what is really a while loop? Sorry, what is a for loop? But a while loop that breaks and has like init logic and breaking logic and checking logic just in specific places. Imagine this. What if I said, before the loop starts, let's say we're going to do a while loop. Before the loop starts, I'm going to initialize a variable, size type I equals 0, right? That's the initialization part. That'll only happen one time. It won't be part of the loop body. And then when you have a while loop and it checks to see if it should keep going, that's the check part of the for loop. So I'll just say while I is less than 99. And then for the update part, we just have to stick that inside of the while loop somewhere. Depending on your logic, you might want to put it at the top or the middle or the bottom. I'm going to put it at the bottom because I'm going to expect that it happens right before we do the next check. So I'm going to maybe do a comment here and call it the update part, and I'm just going to increase I. So maybe if I update this code to print something, it'll seem a little bit more clear. Value of I is, and then I'll just say I and L, and then I'll copy paste that to here. And then I can also put this inside of the while loop. And now we have transformed our for loop into a while loop. Once you know how to transform your for loop into a while loop, it's pretty easy to implement in assembly if you already know how to implement while loops. So I should again say that there are lots of parts. I don't know if I said that during this video, but there are lots of things in this video that I'm not going to explain specifically because I've already explained them in other videos. So for example, implementing a while loop is in another video. So if you don't already know how to implement while loops, if you don't know how to use conditional branching or unconditional jumps, if you don't know the basics of assembly, hybrid programs, make files, all the basic stuff that I'm going to skim over in this video, then you should probably check out my other videos first. But for now, I'm just going to assume that you know how to implement a while loop. And really the lesson is, hey, just take your for loop and convert it into a while loop. And then you can implement the while loop pretty easily. That's the secret, as far as I'm concerned. So imagine this now. Let's do some assembly code. So I have a source code file here called looper.asm for assembly. And you can imagine that I have a hybrid program running under the hood. I'm not going to show you all the code involved. I'm not going to show you the makefile or the C++ driver that calls on this module. We're just going to write the assembly here. So, if you're writing pure assembly at home to practice, that's fine. Just keep in mind there's like a few things under the hood that I'm not showing in this specific video. So first off, I'm going to copy paste my data section of my assembly program. The first thing to note is we have a bunch of C strings here. We're basically going to be telling the user, hey, we're going to begin the for test. Maybe I should have capitalized for. I'll leave it. And then we're going to prompt the user for a number. We're going to say, please enter a number. the loop will print from 0 to the number -1, which is like the typical for loop that you usually write in the most basic case, and the one that I just wrote. And then we're going to have a little prefix. We're going to say, like an arrow, and then we're going to print the number back to the user that we're looping through. So if the user enters a 10, it's going to print the arrow 0, and then arrow 1, arrow 2, all the way up to arrow 9. And then when we're done, we're going to print an ending message. So this is nothing new if you know assembly already. Just C strings that will print with system calls. See my other videos if you don't know how to do that. And then a CRLF string, just basically doing a new line, a carriage return new line feed on the system. And then we're going to output using system call code 1, and we're going to use file descriptor 1 so we can print a standard output. Okay, so now the real fun begins. Let's start our text section, which is where the instructions of our assembly program go. So I'm going to do text section text right there. And I'm going to use 2 external functions to just help me input and output numbers to the user. If you wanted to, you could use a system call that just inputted a character, and then you could just kind of like loop printing various characters. And like, let's say if the user typed A, maybe you could imagine doing a loop that increases the character that they typed all the way until it hits Z. Or if they hit, F, it'll just print F all the way to Z. You could do that without using an external library for printing integers. This video is not about this library right here, so I'm not really going to go over it. But, you could hard code the start and end points when you're practicing. You could use a different library or a different function call to get the inputs. You could use a system call just to input one character. Or you could, use a hybrid program to utilize printf and scanf. Either way, I'm just going to be using these 2 functions just to like get input and output. It's not really part of the idea of looping. So now let's start our entry point. Our function is called looper. Since this is a hybrid program, you can imagine there's a C++ module elsewhere calling on the looper function. And so that's why I mark it as global, so it can be called upon. And then I have another function called forTest. I don't really know why I chose to do it this way, but I wanted to make another function that was called upon by our entry point here. So the looper function really doesn't do anything except for call the forTest function. So now let's start the forTest function. Actually, maybe this is where the fun begins. So I'm going to put it down here. And so you can see the signature. It doesn't take any arguments. It doesn't return anything. It just does stuff. And then I have a note to myself. This is how we're going to use the registers. We're going to use R12 for the user's number. And then we're going to use R13 to keep track of where we're going. So let's see. I'm going to start by saying, let's preserve R12 and R13 because you have to respect the application binary interface, the ABI, and that designates R12 and R13 as Callee-Saved registers. If I don't preserve those and my program is even a little bit complicated, I'm probably going to be debugging forever, or I'm going to just crash my program for no reason. So I'm going to just do a push pop pair. Notice how the pops are in reverse order. This is not a push pop video, but just so you know. I guess while I'm here, I'm going to copy paste my CRLF function, which really does nothing. It just prints out the CRLF string with the system call. That's all it does. Very simple, but then that allows me to just call CRLF. Okay, so do I even need CRLF in this program? I think I just modified this. Maybe I don't even need it anymore. No, I guess I do. The first thing we'll do is we'll print an introduction message to the user. So inside of the forTest, we'll just use the system call to print out, a welcome message to the user. And then I'm going to call CRLF, which will just give us a new line. And yeah, you can hard code, the 13, 10 at the end of these strings, but I don't really like doing that. Okay, so we should have a working program at this point. Let me see if it actually does work. Clear and make run. Okay, so the driver prints a little welcome message. You don't see the driver code, but that's what it's doing. And then the forTest prints the welcome message that we just added. And then the driver lets us know it's retained control, and then it's responsible for returning to the operating system for us. Okay, so then the next thing we're going to do is we're going to ask the user for a number so that we know how many times to loop. And again, you could hard code this number if you don't want to do I/O right now. You could even print a character a certain number of times if you don't want to even deal with printing an integer. But I'm going to ask the user for a number. That's going to be the prompt string. And if we run it again, now you should see it asks the user for a number. So it's going to say, please enter a number. The loop will print from 0 to n-1. Doesn't actually ask for the number though. It doesn't actually, I guess, take the number. So that's going to be my external library that this video is not about, where I just call a function called input assigned 64 integer. And I'm going to receive that back in RAX, and I'm just going to save RAX into R12. So R12 is now going to be the number that the user inputted, and that's why up here I have it designated as the user's number. So really not a big deal, but you know, if we run it again, it'll ask for a number, and then it won't do anything else. It'll just kind of quit. Okay. So now we can implement our for loop. This is going to be a little tricky. So we're going to start off with the initialization part. Remember, we had several parts here. If I just kind of drag this off to the side, maybe pin it up to the top so we can see it. We had many parts. And I guess we're kind of covering that, aren't we? If I move it a little bit to the side. So remember that for loop, it's got an init part and a check part and an update part. And I've kind of added that as a comment just to remind myself of the way my mind is supposed to be wrapped around this concept. And so I made another comment here with for and then empty parentheses just to denote that some comments that come below are going to actually be parts of, I guess, the top of the for loop. So now I'm going to make a label here. And what I like to do with my labels is I like to prefix them with the name of the function that I'm currently in, and then an underscore. And that kind of helps me keep track of my symbols a little bit more easily, especially if I have a large module. The symbols are less likely to overlap if I prefix them with the function names. So here, for test is the name of the function we're in. So everything is going to be for test underscore something. And since I'm only doing one thing inside of the for test function, I'm just going to have a suffix only for the most part. But you can imagine if you had more parts inside of your function and it started getting a little cluttered, you might want to have, you know, another label, you know, that just another, I guess, like part to your label that names the part of your function you're in. Although this is assembly, it gets really hard really fast. So if your function is even a little bit complicated, you should probably consider breaking it up into multiple functions if you can. We can't really do that at this point because it's just a for loop, but keep that in mind. Okay, so we're going to initialize. Remember, the first thing we had to do to initialize was, you know, setting I to 0, or, you know, whatever it is that we're going to set up in the init part. So I'm just going to do that here. I'm going to say move 0 into R13. So basically R13 is equal to 0. That's the first part, the update part where we set size type I equals 0. In fact, maybe I could do another copy paste of this where instead of using a size type, we'll just say that the register R13 equals 0. I know that's not going to make sense in a higher level language right now, but just so that the for loop looks a little bit more like assembly, we'll keep going as long as R13 is less than R12. And then we increase R13. So I'm just going to put inc R13 so it looks more assembly-like, even though this completely and totally would not compile in C++. I hope that this helps your understanding a little bit. So yeah, we can do everything except for just the increase part at the very top. I'm going to choose to increase it at the bottom. If you wanted to, I guess you could start off R13 as a negative number and then increase it at the top. But I personally don't feel that's like very clean. It also forces you to use signed integers. Maybe you wanted to use an unsigned integer so you could get like a gigantic maximum number that you looped up to. I don't know. So we'll just initialize here and we'll say R13 is equal to 0. The init part should not be part of the actual like looping. Like every time you loop up to the top of the for loop, you should not repeat that part again. It should only happen once. So the next label that I have is called loop top, and that's just going to be the top of the loop that I continue to go back up to every time I want to see if we're supposed to continue looping and then go into the loop's body. So maybe I should say that's why this is named underscore loop top. And I don't know, you don't have to do camel casing in your labels, you know, you could just do loop init or whatever, but I'm just choosing to do it this way. So at the top of our loop, we'll be checking to see if we should continue. Remember that was the check part, right? So we're going to check to see that R13 is still less than R12. If it is, we'll continue with the for loop. If it's not, then we jump out of the for loop. So that means probably the true case where R13 is indeed less than R12, that's going to be a short jump just into the loop's body. And the false case where R13 is not less than R12, that should probably end up being a much longer jump. And depending on how big your loop is, maybe that jump is too long, too far away for a conditional branching instruction to reach. If you've watched my previous videos, you should know already that the conditional branching instructions like JL, like jump less than, they can only reach about 128 bytes away. If you try to go further than that, the assembler will actually stop and block you from finishing your compilation. It'll say, I think it's like jump out of range or something like that. So you want to try to keep the short jump points with your conditional branches, and then in the false case, where the conditional jump doesn't actually, or the conditional branch doesn't actually do anything, then it falls through to the next instruction where you will have an unconditional jump. And remember, the unconditional jumps, they don't have a limitation of 128 bytes. They can jump like all over the place, like they can jump anywhere basically. So that means, if you think about it, we come in to the loop top right here, we immediately do a compare instruction and a conditional branch. So if R13 is less than R12, meaning we should continue to for loop, then we'll just do a short jump into the loop's body and actually execute its body. And if not, we will end up falling through to line 92, where there's just an unconditional jump instruction that just says, all right, let's jump all the way down to being done, which could be very far away for all we know. Okay, so we've done that. Now let's implement the loop's body, because the first thing that we did is we wanted to jump into the loop body to actually execute our instructions, which in this case will just be, printing a number every time we loop and then increasing that number. So I'm going to do a little like new line there, and I'm going to paste the loop body. Notice also that I've added little comments to help remind myself that this is actually the loop's body. So for test loop body, that takes care of the branching instruction, hitting on that, and actually going into the body, and then later we're going to have to implement a label for the loop being done. But for now, we'll just say the body. What does it do? It just prints a little message to the user. If you look at the message for current number string, if I go up real fast, message for current number, it's just an arrow. So the user is going to see an arrow and then their current number, I guess of the loop's current number. And then every time it loops, it's just going to continue printing that arrow with a number on it. So we're doing that, and then we're going to say R13, which is the current counter variable, which started at 0, is going to get loaded into RDI, which if you watched my other videos is just the first integer argument for a function call. So I'm just going to call this other function here, which is not part of the video, to just say, hey, please print this number for me. So the first time this iterates, it's going to print 0, because it's going to print R13. And then it's going to print a new line so that the cursor goes to the next line of the terminal. So that's all the body does. It just kind of like prints the current number with an arrow and does a new line. And then at the very bottom of the loop body, we just sort of maintain the for loop. This is going to be the update part. So like, let's see, maybe scooch this up a little bit. The update part where we have, let's see, on the very right side of the for loop, which is like I++, or in more assembly speak, increasing the counter variable. So I'm just going to increase R13, and then that way the loop can progress. We're always looking at R13 to decide if we need to stop or not. We're comparing R13 to R12. So we're just increasing at the very bottom of the loop, and then we unconditionally jump back up to the top. Probably a better idea to unconditionally jump back up to the top, because maybe the jump to the top is very, very far, and if it's greater than 128 bytes, it won't work. So the regular jump instruction doesn't have that limitation. So now we're jumping up to the loop top. So you can imagine now that, we're not going to the initialization part. That would be bad. We're just jumping up to the top here, where we immediately ask, are we done? If we're not done, we jump into the loop body and print another number. And then at the very bottom of the body, we say, all right, increase the counter, and then jump back up to the top. So this is a simple for loop, but you can see what it's doing, right? It's just going to be printing a number over and over again as the number increases, and then eventually it'll stop when it hits the correct number. The last thing we need is the loop done label. If you look back up at the top here on line 92, if R13 was not less than R12, then execution would fall through to line 92, and there is our unconditional jump instruction, basically saying if R13 is not less than R12, then we'll jump to the loop done label, which means we're just totally finished with this loop. So we have to make that real fast. And all it's going to do is just basically say goodbye. It's just going to print a message to the user with the system call a CRLF, and then fall through to the restoration functions. Oh, did I ruin my return somewhere? Uh-oh, what did I do wrong? I lost my return statement. Did I accidentally delete that somehow? That's a bad program. Or did I not even? I wonder if I wonder if I didn't have my return statement and it fell through into the CRLF function, and then the CRLF function returned to the caller on behalf of the for test function. I don't even know. Only the spirits know at this point. I don't know. Leave a comment or something if you know what happened. But every function has to have its own return for sure. So, the loop done label is usually where you want to jump to when you know the for loop is finished or the while loop is finished. When it comes to saying goodbye, it probably would be a little bit more clear of me to add an additional label specifying, for test, say goodbye, just so that I remember that this is the place where we're done, and this other place, this is just something else that's happening. Maybe I'm doing more instructions or more operations, or I'm calling a function or whatever. So obviously, if I did it this way, then the loop done label would just end up falling through to the goodbye label, and it would be fine. But it's just more visually clear. I'm going to take it out, though, because I don't have that in my solution. Anyway, so at this point, we might have a program that actually works. Let's see if it does. What else do I need to add? No, I think we're done with that. Okay, let's try it. So we'll do a make run, and we'll enter the number 5, and let's see if it works or it crashes. It worked on the first try, so I had a solution, though. Not fair. But I could have typoed. Anyway, so it says we entered a 5. The loop will print from 0 to n-1, so we should see from 0 to 4. And so then every iteration of the loop, it's just that little message. We're just printing a 0, printing 1, printing a 2. The number increases because we did that little INC instruction, the increase instruction. We unconditionally jump to the top of the loop where we decide if we're supposed to finish, be done with the loop by jumping to the done label. Eventually, after we, let's see. Eventually, when it prints this 4 here, it'll do the increase instruction at the bottom of the loop's body, and then it'll jump to the loop's top. Then the loop's top will see that it's a 5, because we just increased the 4. It will see that 5 is definitely not less than 5, so that's a false, which means execution will, fall through. Where the heck is that? It'll fall through to the line 92 jump instruction, which is just the loop being done. So that's here where it says goodbye. And then we have successfully implemented a basic for loop. All right. So thank you so much for watching this video. I hope you learned a little bit and had a little bit of fun. I will see you in the next video. Happy coding and happy studying. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness, which is coming for us all.